Hello and welcome everyone to the webinar on world model, next big thing in AI. My name is Tanay and I'm joined with Tanuj Parashar in hosting this webinar. This is a moderated webinar, so please feel free to put your questions in the comment section and we'll get back to you after the webinar. Before we go into the subject matter, a quick note about FutureBridge. So FutureBridge tracks and advises on the future of industries from a 1 to 25-year perspective. For more details, please visit us at futurebridge.com. Now, coming back to the agenda of today. So we wanted to discuss in this webinar what are world models, a quick introduction of that, where are they being used and where their usage will be most beneficial in going towards AGI, and ultimately what do we feel about the events that are going to happen and what are the timelines for that. So these are the key things that we would like to discuss today, starting with a quick introduction on world models. Now, I'd like to start why we have to think of world models. And if you look at, current AI systems, so chat GPTs and other chat systems or other LLMs or even multimodal models, the challenge with them is they do not have sufficient ability to correlate cause and then accordingly predict the effect. The reason behind that is a lot of their, let's say, thinking is built on simply the text data or images even, but a very few model, if any, are being trained using videos. And the general ability to essentially learn what will happen next in a physical environment can only be learned through a let's say a multimodal model which is trying to predict what is going to be the next state of the world around it, right? And that's not the case in the current architectures that we have for AI systems, which essentially means you're not building a model of world around you and then are not able to predict what is going to happen. And because you don't have that picture, you don't have that view of how the world is changing around you, you can't plan the right things. You can't go ahead and reassess what is going to happen. Is there an obstacle in front of you, or how will that obstacle behave? And based on that, you should be able to, let's say, move around or take appropriate action. But that is not happening in the today's AI systems, which again, we discussed slightly about that lack of multimodal thinking. So again, we are not thinking, even in the reasoning models of today, we are doing most of the reasoning and most of the thinking in text format, and you don't have anything being generated as a let's say as a video or a three-dimensional world, or not even a latent representation of what might be happening in the three-dimensional world. So you are essentially doing a one mode or text mode thinking without a lot of consideration to real life physics. Right. We already talked about simulation and predictive actions. Because you're not simulating, you're really not doing predictive actions for the simulation. And that's how typically we would consider what we as a human are doing. And embodiment of AI for learning from the world. So if you have this kind of AI models which are able to predict the future of your surrounding, you can then act on it, and then you can do the reinforcement learning as to whether what you predicted indeed happened, or the result of actions that you predicted that also came to pass. And if we can enable these kind of models inside these AI systems, we can make this loop of reinforcement learning from the real world. Yeah. So let's go to the what understanding a bit what world models are. So now, as we slightly touched upon earlier as well, world models are based on what humans do in principle. So we imagine stuff, we imagine the effect of our actions, we imagine the world or how the surroundings will change, and then accordingly take actions in this physical world, right? And that's the main thing, which is ability to imagine or ability to think what will happen in the physical world and the future state will be, right? And accordingly, the models, the world models, should be able to create 3D representations or use any kind of input data. It could be pure text, but it could also be videos and images from surrounding to have this either explicit or a latent visualization of the future states, right? That's what we are trying to achieve or rather, that's what the world models are trying to achieve. And once they do this, they can also enhance these models by incorporating, of course, the physical law, the spatial properties, also the material properties like softness, texture, how things will interact with each other, whether things are bouncing or collapsing, and so on and so forth. And that definitely, make the prediction much more accurate, which will make the thinking much more accurate, and then of course the planning much more accurate, which improves the decision making properties of these kind of systems. And where we will see this being used the most is, of course, in the physical systems. So like robots and autonomous vehicles, these will be the ones to first benefit from the world models. And in fact, many people believe that world model, or at least the concept of world model, is essential for the AGI or human level intelligence. Yeah. So
Okay.
we can.
Okay. Here we look at a very simple schema of the world model. And particularly if you focus on the box in the red outline, then you will see over here that there are two major components. One is the vision and another is the memory. So world model works on two aspects primarily, which is perception and prediction. So vision model takes in input, that's perception, taking a high resolution image, and then it converts it into a low dimensional vector, which can be fed into the memory model. Memory model is based on neural networks, and it's able to predict what could be the what could be the next state of this. So based on this schema, they are based on RNNs and VAs, both of these models. But again, the concept is not to restrict it to one kind of network. The technique can be different, but the basic concepts are same. Perception and prediction. Over here, you can see another component, which is the controller model. So, because this is the kind of an application that they have shared, which has the gameplay, a car moving along a track. So, how better it is able to restrict itself to the track. So the controller model, what it does is it takes input from the initial picture snapshot, which has been passed on to the vision model, as well as the predicted state. And it selects the most optimal outcome. And then this process is repeatedly sort of done so that model is trained. And when maybe, around 10,000 of the times this cycle is done, then we see model behaving in the way that we want, and it's able to sort of, the car is able to go alongside the track. So this is a very basic model which was launched in one of the papers by a very well renowned researcher. Now moving on, I'll take a brief pause before we move further. So we have got a basic understanding of what are world models, and a very simple view of from technical aspect, what how a world model would be enabled. So I would like to open this question out to you. Recently, there's a lot of hype about DeepSeek, and it's based on it's like a very proficient ChatGPT competitor. And since 2023, LLMs have been at the forefront of the AI and overall AI domain. So where do you see world models playing a role in terms of how are they able to fit in this LLM landscape? Are they ahead of LLMs? Are world models will be playing a sort of complementary role? Would they be working together? Where do they have an edge over the LLMs particularly?
In our understanding, the world models are definitely a part of the overall AI architecture, and definitely we see LLMs and world models being coexisting and being developed for different applications, right? So the efficiency and the accuracy that you can get with LLMs today is definitely much higher as compared to our ability to predict the future of a physical system, right? So for foreseeable, let's say next 3 to 4 years or 3 to 5 years, definitely LLMs, I think, would still rule most of the commercial and chatbot like applications, but world models will become essential for more physical embodied applications. So whenever we are talking about robots and self-driving cars or AMRs or any system that has to do a lot of action in the real world, as well as a lot of systems that maybe are doing, even things like chatting or text generation. But if their applications is around, or the chatbot is around something which is physical, right, then it would definitely help to have a world model element to those. So let's say if you're talking about a, just hypothetical sake, if we are talking about a commentator for a football game and we are making a model for that, right? It would definitely make sense to have a world model being part of this system where you can know about the directions and you can understand the pitch and understand, the physics of the game, right? Whereas if you're just trying to make code or you're trying to write chats, then maybe you can live with just a pure LLM based chatbot.
Thanks, Sunil. That was a very interesting example, and I think people who are here participating can very well relate with us. So, just extending it further, let us look at the few drivers and applications of these world models. Primarily, if I look at these models, there are two main aspects. One is data and other is resources. So there are many scenarios. For example, let's say deep sea drilling and high risk, rescue bots. So there are different critical scenarios where you need to we use robots, but these robots cannot be used as effectively as they could be. There's a lot of hype about humanoids, but how much smart they are. It is because there is so much variation in real world that you cannot effectively train on each and every aspect. It would require a lot of data, humongous amount, and same amount of resources would be needed. So we need 3D environments in which these robots or, let's say in autonomous vehicles, we have been focusing a lot since maybe last 10 years. And big companies, like Google have invested significantly. But still, there is a sort of barrier in terms of crossing that threshold so that we can actually rely and believe in those systems. So I think here world models can make a big difference because they are able to train these applications on real world scenario, helping them to build an understanding of the world. As I was saying, if a commentator, if it's just English understanding what's happening and just generating words, that's one thing. But in order to actually understand, like how a ball would rebound from here to there, and then how much like would that require a header or would that require a kick? These kind of aspects are intuitive, which would certainly require these models. Going further, yeah. So let's look at what's happening in the industry. Primarily, majority of the big players, Microsoft, Google, Meta, they are investing in world models. They have either in their research wing or in some sort of applications. They already have these models placed. They are using maybe internally. Some of them, like Google, has announced, it launched Genie. OpenAI launched Sora. A common theme around this is currently what we have for users to try and experiment is related to creating 3D videos, 3D worlds, which can be used for training systems. So these are kind of applications that are currently being built upon. Very recently, NVIDIA launched Cosmos. So this Cosmos has a suite of world model related offerings, which covers, the like world models which can be further fine tuned, which covered guardrails, which covered tokenizers. So all these are building blocks of these models. Okay. Now, when we look at the broad level of applications across different sectors, so as you must have already seen, two prime industries which are currently being focused upon are robotics and autonomous vehicles. Why? Because they are the ones which are already in very much sort of demand. A sort of significant investment has already been put in, and these models are able to take them a leap forward in terms of the physical AI experience that currently has been lacking. In addition to robotics, the next sort of prime industry example is from gaming because uses a self-supervised environment through which the game plays. They can be trained before actually being implemented in a sort of live scenario. In terms of video generation, we can witness its adoption in the media sector because the current video, like currently through the existing applications from, and similarly, like image generation, media generation, Palmy, etc. So they are also able to generate, but the kind of variations because of their AI techniques can be significantly different from what world models are able to generate because they have an understanding of the real world scenario. Similarly, we have other applications which can be witnessed in the healthcare and governance sector. So, in healthcare related to formulation of drugs, trying out different, scenarios, formulations. In governance, I think it could be a very significant leap if it gets implemented because it can be a demo for policy implementation. So, for instance, if there is a policy related to a certain aspect of the, roadways or the railways connectivity, so how would it impact in real world? I think it can be a good scenario building formulation before the actual policy or the regulations are being launched out for the public. I take a brief pause here. In case you have any questions, you can feel free to share it in the chat box. Let's move forward. And before we start with this, again, I would, ask Tanay to share his thoughts on a very important topic because a lot of the participants we have today are at a senior level in different departments of, engineering, R&D, digital transformation, from equipment manufacturers to manufacturing players as well. So now we have a basic understanding of these world models, but as a customer or as a buyer, what do I have to, what do I need to know and what do I need to do? Let's say how these models can impact me 1 year, 2 year, and 5 years down the line. So that's something would be interesting to know. And I'll put back the slides as well, but you can start, please, sharing your thoughts.
Yeah, definitely. I mean, there is a very rapid progression of AI's ability to answer different types of question. And this could essentially mean ability to have better robots, ability to have better mobile systems, and ability to have better decision makers in general using AI, right? Let's say if we have to make it a bit more concrete, so what kind of capabilities will we see in the, let's say, near term and long term? In the near term, we definitely foresee ability to train robots using these kind of systems. So general purpose robots which are able to adapt to the environment and to the task. Those kind of robots would definitely learn or will be trained using these kind of world models, right? A lot of that has already started to happen within explicit world models. So if we talk about gaming engines and even some of the models, some of the platforms provided by NVIDIA, they are a lot, what should I say, explicit, but there could be representations of world model which are implicit, which are in latent space, and they can also start to come into the picture. So first application, very near term, robotics, autonomous vehicles, and systems like that. And of course, autonomous vehicle might still have some time because safety and people are involved. But for the closed space industrial application, we definitely see them coming into the commercial adoption and so on. Better than human performance on certain benchmarks. Now we're talking about specific benchmarks for things like OpenEQA, so question answers, and general reasoning. These kind of benchmarks, which doesn't let's say cover the entire human general intelligence, but still at least on certain reasoning benchmarks, using world models, AI systems will be able to surpass human level intelligence within next 2 years. Yeah. Slightly in the longer term, and longer term for AI would be 2 to 5 years. What we can definitely foresee happening is physical systems like robots are able to handle the hard manipulation tasks. So difficult things like handling clothes or folding laundry and handling delicate items, operating tools, so things like cooking and slicing tomatoes and stuff like that, those will be enabled within early long-term future. So let's say 2 to 3 years now. These will be things that are really possible. Slightly longer term, so let's say 3 to 4 years, we are going to see human-machine or machine-machine collaboration, which is completely not prompted, in the sense that you have a goal and you give that goal to the machine and put them in a space, and then they are able to collaborate between them without any training. So they are pre-trained to the level that using their internal world model, they can think onto how to act in this space collaboratively so that the goal is achieved, right? So that will be a big task, because then you can put a bunch of machines out there and then ask them to work. Because if you have just one machine and maybe it's intelligent, inability to collaborate could mean that it is not able to do a lot. But if you have a bunch of machines in an environment without having to code responsibilities and roles, and you are able to give the overall objective and they are able to collaborate internally, that would be a game changer, right? And lastly, let's say 4 to 5 years, machines should be able to develop an active theory of mind. So as of now, we don't have any, let's say, a representation of the world in our AI systems. Slowly, these AI systems will start to have a representation of the, let's say, the three-dimensional space. Over time, the physical laws and systems of physical rules would also be integrated in that world model. And farthest, say in, let's say, 4 to 5 years, our world models would also have actors and their thought process. So let's say in an environment there are multiple people, and the AI should be able to model what they might be thinking, not only how the physics will act, but also have this theory of mind of the all the actors that are there in the environment. And that would be very close to human level thinking, or the way humans think and react in the world, right? And then of course, for 2030, anything is possible. I think many people predict 2030 is the time of singularity or AGI. And yeah, I think our assumptions would also align with 2030. 2035 is when we see the AI systems smarter than the entire human population and so on. But yeah, I mean, 2030, 2035 is quite far in the AI terms. So yeah, keep in contact with us, and we keep you updated on what is happening in this space. Thank you from our side to all participants on this webinar, and we'll speak soon.